Hello again, poetry lovers. The purpose of this video today is to show you my new kitchen galley and show you what went into making it. Now let's get into some of the construction details, and it's much easier to see those from this side of the van. First of all, I used my 4 of my horseshoe clamps on the jump seat holes to hold down these 2 pieces of 40/40 extrusion. The main reason for these 40/40 extrusions is to hold down these 2 main rails that everything slides on. This is 1020, which is roughly equivalent to 2550. Van Duit uses the 25 series. It's much easier to get the Imperial size series locally. As you can see, these are just drilled straight down. There's some screws that go in there. I've got a little reinforcing thing here. I'm going to put one over here as well. I'd like to make this as solid as possible because when the fridge is pulled out, there is a pretty large force trying to pull that up. I'm not worried about these M8s, but these M6s are probably the weak point. Now, what I did to make the sliding mechanisms, I actually have 2 different drawer slides. You can see that here. So here's my main rail again. That's the thing that's attached to the 40/40 here and the 40/40 way back there. And that's cantilevered out here. This black 40/40 is really just a floater. It's only attached to the rails, it isn't attached to the floor. But that's okay because it gives some support to the cantilevered end of the main rails. Now you can see I have a drawer slide that's running on the inside of the main rail and a drawer slide running on the outside of the main rail. Did I do that for strength? Well, not really, because the claimed load-bearing capacity of each of these slide sets is 264 pounds. It is probably unnecessary, it's definitely unnecessary, I should say, to have 2 of them. But what I wanted to do was I wanted the fridge to slide out 16 inches. If I got a single 30-inch drawer slide, the fridge would not stop until it got to 30 inches, which would put it hitting the back seat. So I have a 16-inch locking slide here that controls the limit stops of the fridge, and then I have an 18-inch slide in the back just to support the back half of the fridge. I mean, you know, in theory, the single 16-inch slide is strong enough, but in reality, it's only under half the fridge, and I was afraid of the fridge sort of, tending to tip on the slide. So I put the 18-inch slide in the back, which you can see here. Actually, you can see the track for the 18-inch slide right back there. These 18-inch these slides are held in with some M5 bolts. That's the largest screw you can put through the holes in the slide. Here are the M5s. Okay, this is what it looks like from one side, and from the other side it looks like this. I drilled I think a 5/8 hole to get a socket in there, and those are some nylock nuts on there, so I know those won't loosen up. So there's at least 4 M5s on every slider plate. There's a pair of plates here. There's a pair of plates on the other side. There's 2 more pairs of plates in the front here. I had to put them on opposite sides of the track because they would interfere with each other. I chose to put these 2 on the inside because I wanted to get these levers closer to each other. Now, as I said, I'm going to create some kind of a plate that joins these 2 levers that I can either step on or rig up some sort of a handle that I can push down on and slide the fridge in and out. Now, the other purpose of these cross pieces is to hold up the vertical struts. This one, I made a separate post about. I needed an adapter here to convert the single channel 40/40 to a double channel. Then, once I had a double channel, I could use these really fancy butt fasteners. This thing is incredibly stiff because it's got 2 butt fasteners on each side. And initially, my plan was to run a cable from this front corner up to the ceiling cross piece, but even though that supported weight, it didn't keep the whole thing from just bouncing up and down as you drove down the road. So I ended up adding a support here. The reason I didn't want a support here is because I want to keep this area, you know, as free as possible from trip hazards and so forth. The entire fridge is suspended here over the floor because this serves as a toe kick. Just like you would stand at a normal kitchen cabinet and have a toe kick, I want a toe kick here as well, so you don't artificially have to stand with your toes touching the front of the cabinet. Also, because I will eventually have seats and such over here, I want to be able to get as close up and personal to this as I can. Now down on this end, and this is where the majority of the support for the countertop comes from, I have sistered a couple of short sections of 40/40 to the cabinet, and then I put this big cantilevered 40/40 out here that's holding up this entire end of the countertop. Now up on top here, you can see exactly the countertops that were from the old kitchen pod. This sink is rather close to the bed. I don't like that so much, but I'm going to explain what I'm going to do about that in a minute. One of the other main reasons I built my own pod, instead of just extending the existing pod, is I don't believe the pod needs to be this deep. There isn't any reason to have this much space here in front of the sink. The only reason the factory kitchen pod is as deep as it is because it perfectly fits the length of the Dometic cooler that Van Duit offers as an option. But if you're not using the Dometic cooler, you don't need a countertop that's this wide, and in a van, every inch is precious. So I can easily lop off 2 to 3 inches here and make this thing narrower without compromising its function at all. I obviously don't want to take off more than gets me down to the width of the cooler. So probably I'm going to take off about 2 inches. But I wanted to set it up quickly just to see if this idea even had legs before I start mutilating, you know, in a non-repairable way, the factory kitchen pod. Now, as I was saying, what am I going to do about the position of the sink? I think the right thing to do, actually, is to take this panel, turn it 180 degrees. Now the sink is over here. But once I've turned this around and all of this real estate is against the back wall here, I will scribe the pillar out and then just push everything back in so that the countertop will be nice and custom looking, custom fit. Here's another little detail I almost forgot to mention. I didn't want to cut the molding here that comes with the van, so instead I relieved the 40/40 here using my milling machine. See how that's been cut back? The same thing over here. I cut a relief channel in the 40/40 so that I wouldn't have to damage the factory molding. And all of this, I hope, helps to explain why it took me a month to do this. And still one more thing that I forgot to mention, a very tricky detail here. These drawer slides were advertised as 2 inches. They're actually 53 millimeters tall. Well, unfortunately, the extrusions are 2 inches tall. So I had to put spacers in here. You can see that spacer in there. To raise these above this, you can see how it just makes enough room. Those are 2 millimeter spacers. I need 1.5 extra millimeters on the top and on the bottom. And so that gave me just enough room with the spacers. Same thing over here. Maybe you can see the spacer better. There's that spacer in there. The spacers are also required on the top in order to have cross pieces clear these accursed drawer slides that are 53 millimeters tall. One last thing I'd like to point out. The galley kitchen is done, air quotes. It's not done, of course. Obviously, I have to trim this. Initially, this thing, these two sets of holes lined up with the two sets of channels here, but then when I added this 1 inch high piece here, everything moved up an inch, so I have to drill a couple more holes. I have to lop this off. Over here, I'm going to probably pirate some of that rounded channel from the kitchen pod, and I'm gonna cut this back and put a piece of rounded channel here and here, because these are painful. I've already found that out the hard way. I need to get some end caps to cover up all these open ends, and then what else? I need to pull the cooler off and get in there, and you know, now that I've put together all the parts and I know that everything fits, there are places where I could have put more permanent fasteners in instead of using these kinds of fasteners. So I need to go back. You know, this is not suitable down here. That isn't sturdy enough. I need to go back and put some more permanent type fasteners in there. Oh, I just want to point out that I cut things so that these screw holes all line up with channels. The reason I didn't put screws in here is I would have to take this end piece out so I could slide the T-nuts in. I'm still waiting on an order from tnuts.com of some roll-in fasteners for the 10 series. And the same is true here. Under here, I have a double wide extrusion, and the purpose of that is that I can put fasteners here, and I can put fasteners here. But I'm gonna have to pull it out. I'm gonna have to drill more holes in this countertop first of all, which I don't want to do yet. I'm gonna have to pull that piece out if I want to use slide-in fasteners. So I'm just gonna wait until T-Nuts gets the roll-in fasteners in stock again. Also, one thing I never appreciated until I did this is that the spacing on these fasteners is different than the spacing on these. And so it was necessary to put a sister extrusion there just so those would go in, because they don't overlap the outermost extrusion. Here you can see all the kinds of, you know, for quick prototyping, these little angle brackets are great. For more permanent construction, I probably want to do something else. So I still have a little bit of work cut out for me, but overall the concept is proven, and there it is.